but it is important. So this is a way of writing very big or very small numbers as a decimal with a multiplication of 10 to the power of something. So now we need to decide, how do we decide the exponents, and how do we know where we're moving my comma? Okay, so if we look here very carefully, we have a very small number. Okay, this is 0, 0, 0, 0, 0, 0, 0, 0, 5, 3. And I want to rewrite it as 5, 3 times 10 to the power of 8. Now, how do we know, negative 8, excuse me. Now, how do we know what that exponent should be? So rule number 1 is, if I have to move my comma to the right, okay, then I'm going to have a negative exponent. Okay, which means if I have to move my comma to the left, then I'm going to have a positive exponent. Let me move this up a bit. All right, so that takes care of, nice, Kali. So that takes care of whether your exponent is negative or positive. Now, I will always have a base of what? Look at what we're about to multiply both numbers by. Look here. So my base is always going to be which number? Nice, Senyani. So the base is always 10. So let me write it on the side here. I'm making notes for us for people who want to take screenshots. So my base is always 10. Now let's look at where we placed my comma. In the first example, I placed it after the 5, and in the second one after the 6. That is because we want your coefficient. The coefficient is this guy over here. We want this number to be between 1 and 9. Well, from 1 to 9. It has to be less than 10. Okay, so this is very important information. You are not allowed to have a scientific notation that is maybe 15,7. No. Okay, you're going to have to move that comma. Okay, so this is all the information we need for now. And then you just count how many places we moved it. If you look at the first one, 1, 2, 3, 4, 5, 6, 7, 8. That explains where that times 10 to the power of negative 8 comes from. And my second one, if you don't see a comma, it is at the end. So it is here. We're moving it how many times? 1, 2, 3, 4, 5, 6. So that is where the 6 comes from. Okay, so I just said a lot of information right now. Thumbs up, thumbs down. Did you guys understand what I just said? I will rewrite it now in an orderly way. We'll make steps, and then we're going to go into practice after this. Okay, I have a very few thumbs up, but I'm going to take that as we all good and we understand. Thank you, guys. Okay, so there we go. So we have decimal notation and we have scientific notation. And once again, this is just a repetition of what I said. Okay, this is my coefficient. The base is always 10. And then we have an exponent. Now, depending on where we move it, we'll decide on whether it's positive or negative. And then we will count how many times we move. So I'm going to put this in steps, okay? So my step 1 is going to be place your comma. Okay, so we want our comma at the first digit. After the first digit, that is less than 10. Okay, so 1 to 9. There. Place your comma. And then once you've placed your comma, times 10. Okay, because we're always going to use the base of 10. Okay, so let me write in brackets here. This is always. Okay, now we need to decide if my exponent is positive or negative. So I'm either going to move my comma to the right So if it's there and I'm moving it right, that means I'm going to have a negative exponent. Exponent, not exponent. Negative exponent, or left, which is a positive exponent. Okay, so after you move my comma, you have to count how many times you move the comma. Okay, so that's it. Those are our steps. So take, yes, Tali, you may unmute.
Ma'am, I wanted to ask, ma'am, you see the first one where it says 6, 13 times 10 to the power of 6. Ma'am, how is it to the power of 6, ma'am? I wanted to ask, does it go with the number of zeros to get the power?
No, remember I said, Tali, if you don't see the comma, it's at the end of the number, right? Which means it was over there. Do you see it?
Yes. Ma'am, how did we get the 6?
Because we want our comma to be after a number that is less than 10. If it was over there, is that number less than 10?
No.
It's going to be 61, right? Which is what we don't want. So the first number that is less than 10 but bigger than 1, that's where we're going to place our comma. Do you understand?
Yes, ma'am.
So now we know we want it over there. So now, am I moving my comma to the left or to the right? If it was
To the
here,
left.
there we go. We're moving it to the left, which means my exponent will be positive or negative?
It's positive.
Positive. Now let's count how many times we're going to move it. I'm starting over here. 1, 2, 3, 4, 5, 6. Do you see where that 6 comes from?
Yes.
Do you feel better now?
Yes. Thank
Wow.
you.
You're welcome. Okay, so there we go. We did a nice example there. Thanks to Charlie. Now let's look at this one. The first number that is between 1 and 10 is the 1. 1, 2, whatever, right? Now we look, am I moving this comma to the left or to the right? If initially it's over here, that means I'm moving it right. And if you look here, right means negative exponent. So that's where that negatives comes from. And if we're counting, we start over here, 1, 2, 3, 4, 5. That's where this 5 comes from. Okay, guys. Hopefully we got that all under control and we all understand. Now let's practice. Write the following in scientific notation. Step 1 was we have to place my comma. So for A, if I have 134, 56, where do I want my comma? After which number do I want my comma? For number A. Senyani is 13 greater than, oh, there we go. There we go. After the 1, right? So we want our comma here. Another little tip that I forgot to tell you guys, you must write all the numbers that are not zeros, okay? So if you look over here, we only wrote the 6,13 because the rest of them were zeros. You guys see that over here as well? We just got rid of the zeros. But if the 0 is between numbers, if I have 1,1057, you better write the 0. You cannot change the number because it's between 2 digits. Okay. So I have 1,3456 because I have to write all my numbers. Now, times 10, because we know we're going to have a base of 10. Did I move this comma left or right? Initially, it was over here. So did I move it left or right? To the left. So is my exponent going to be positive or negative? Nice, Tlali. It's going to be positive. Positive what? How many times did I move it? Look carefully, Senyani. Where was it and where is it going? Look carefully, guys. Pay attention. So it was here. And it's going to move 1, 2 times. That was horrible jumps, but you guys get the point. Let me use a smaller pen maybe. It was over here. So it's going to go 1, 2. So then my exponent is positive 2. Everyone else is very quiet. Do we understand this? Can I have at least 10 thumbs ups or thumbs down? If you don't understand, you give me a thumbs down, okay? We don't just keep quiet. Okay, I have 6 thumbs up so far. Only 6, 7, 8, 9. One more person. I need one more person. Thank you. 10. I got one in my DMs. Thank you very much. All right. Let's do the next one, okay? So we're on number B now. And we have 1, 2, 3, 4, 5, 6 zeros. So it's 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. Where do I want my comma? Nice, after the 5. Thank you, guys. So I want, it's going to be 5, comma, 6, 7, 8 times 10, because it's always times 10. Am I moving this comma in this case, left or right? Look carefully where it is and where it's going. It's here right now. So I'm moving it to the right. How many times are we moving this? 1, 2, 3, 6. How many times are we going to move this? Oh, I said right, but I never asked. Is it a positive or a negative exponent? Thank you, Clary. Is it a positive or a negative exponent if it's moving to the right? Negative. And how many times? Count carefully. Thanks, Clary. If it's over here, it's going to move. 1, 2, 3, 4, 5, 6, 7 times. So it's to the power of negative 7. Nice. C, number C. 8, 7, 6, 5. While I write this, tell me in the chat if we don't see the comma, where is it? If we do not see a comma, where is it? At the end, right? So currently it is over there. Where do we want the comma? After the 8. So it's 8, comma, 7, 6, 5 times 10. Are we going to move this left or right? To the left. How many times? 8 times. So is it positive 8 or negative 8? Nice. Positive 8. And number D, which is the last one, 0, 0, 0, 1. Where do I want my comma? After the 1, okay? So it's not necessary to write 1, 0, guys. You can just write 1 if it's 1 digit, okay? So I'm just going to write 1 times 10. Am I moving this left or right? Right, how many times? Three times. 1, 2, 3. And yes, it is a negative exponent. So it is 10 times 10 to the power of, excuse me, negative 3. Okay, now for all of these 4, thumbs up, thumbs down. Do we understand how to get to the scientific notation? Before I move on, you have to get this one because we're about to go in the opposite direction. So if there's something you're unsure of, speak up now. Okay, we're about to do the opposite. But first, I want us to check if these numbers are in scientific notation or not. And if you say no, you need to tell me why. Each of these, are they in scientific notation? And if they are not, we need to fix them. Is A in scientific notation? So I'm going to start off by writing yes or no. Is A in scientific notation? Sinyani says yes. What does everyone else say? Tali says yes. Sinyani changed his mind and says no. Why is it not in scientific notation? Thank you. 90 is over 10. So where do we want this comma to actually be? After the 9. So it has to be, okay, I'm going to start with, no, it's not in scientific notation, okay? So it's going to be 9, comma, 0, 3 times, okay, there was already 10 to the power of negative 5 there. And now we just move the comma. So I'm putting another times 10. Did we move it left or right? Did we move it left or right, guys? We moved it left. How many times? Once. So is it a positive or a negative 1? A positive 1. Now, are we done here? Are we done with this question? Think laws of exponents. No, what can we do with these exponents? I am multiplying. I have the base of 10 for both of them. So what can we do with the exponents? Nice, Maureen. We can add the exponents. So it'll be 9, comma 0, 3 times 10 to the power of negative 5 plus 1, which means our final answer is 9, comma 0, 3. What's negative 5 plus 1? Times 10 to the power of negative 4. Beautiful, guys. Beautiful, beautiful. Is number B in scientific notation? No. Where do we want my comma? After the 1, but I'm not going to write 1, comma 0, 0 because it's unnecessary. And then we already had times 10 to the power of 2, and then I'm writing again, times 10. Did we move the comma left or right? Left, is it positive or negative? It is positive, and how many times did I move it? 2. So then my final answer is 1 times 10 to the power of, nice, Tlali, 4. I hope I have not lost anyone. Okay, number C, is number C in scientific notation? Yes, it is. There's nothing we can do there about it. Is number D in scientific notation? Yes, it is. We must leave it alone. Is number E in scientific notation? No, it's not. Where do we want our comma? After the 1. So it must be 1, and it's going to be times 10 to the power of, we already had a 3 there. And now here's the one we are placing. Okay, did we move this comma left or right? Right? How many times? And is it positive or negative? Nice. Negative 2. Now let's add our exponents. So it's going to be 1 times 10 to the power of 3 plus negative 2. What is that plus minus going to do? What is these guys going to do? What's going to happen here? They're going to become a minus. So it is 3 minus 2. So then it's 1 times 10 to the power of just 1. Is it necessary that I write that 10 to the power of 1? No, so that's my final answer. Now, be careful. If you get an answer like this, why can't I just say equals 10? Why can't I just say equals 10? What was the instruction? To rewrite them in scientific notation. Now, if you write equals 10, you have defeated the purpose and you will lose your mark. Okay, so don't be tempted. Okay, let's see. Number F, is it in scientific notation? No. Where do we want the comma? After the 6. So it's going to be a 6 times 10 to the power of 8. Now, did we move that comma left or right? Right? How many times? Is it positive or negative? Let me start with, is it positive or negative? Nice, negative, and we moved it once. So it's -1. So once again, we're going to be stuck with the 10 to the power of 8 plus -1. That plus negative does what? This stuff over here becomes a negative. So then my final answer is 6 times 10 to the power of 7. Thumbs up, thumbs down. How was this round of questions? I only have 3 thumbs up. I'm getting nervous. Okay, there we go. There we go. All right, no questions. Screenshots. Let me zoom out a little bit for you. There we go. You can take a screenshot of everything. Then I'm going to move on to doing it the other way around. Okay, if we're doing it opposite, if we're being given scientific notation and we are being told to rewrite it as a full number. Okay. Now, I'm going to take one of these. No, I'm going to make my own. Now, originally, guys, when we were given a number and taking it to scientific notation, okay, I'm going to write here in big red, doing the opposite. Okay, so originally, when we were moving right, would our exponent be positive or negative? It would have been negative, right? And we were moving left, it would have been positive. Now we're going to do the opposite. So that means if I have a positive exponent, where am I supposed to move? The opposite. Right, guys. And if I have a negative exponent, where am I supposed to move? Left. Okay. Are we with me? So we're doing opposites. This is like inverse operations. Okay, so this one, let me say this one, original. And this one is scientific notation to number. Maybe here I must write number to scientific notation, eh? Just so you don't get confused which one is original. So this one is number to scientific notation. And the next one is scientific notation to number. So let's see what I'm talking about when I say we're doing the opposite here. Ne? We need to apply this. So if I have, did I write this? Okay. So if I have a, it's all right, Londeka, welcome. You remember we can watch this video. Okay, it'll be in the Google Classroom. So please, please watch it. So if I have 1,95 times 10 to the power of 4. Now we're doing the opposite. So we're over here. So is my exponent positive or negative? It is positive. So am I going left or right? To the right. How many times? 4 times. But now we have a problem because I only have 2 numbers here. So once you run out of numbers, what do I put instead of numbers? Zeros. Beautiful, guys. So then this will be 1, 9, 5. And how many zeros do I need? So I moved 1, 2, So I need how many zeros? Look carefully. I've taken up 2 spaces from the numbers. 1, 2. I only need to move 2 more times. So there are 2 more zeros. Beautiful, guys. 0, 0. Okay. Let's look at number B. It says 5,53 times 10 to the power of -2. Okay. Now I have a negative exponent. So am I going left or right? Left how many times? Twice. But I only have space for one number. So what do I need to add? How many zeros do I need? 1. So it's going to be 0, 5, 5, 3, and this 0 over there. Do you guys understand? You can't just leave this comma hanging. You have to add a 0 before the comma as well. So now we've only done 2. So thumbs up, thumbs down. Tally, unmute, my darling. Where did I lose you?
Isn't the exponent
Isn't the exponent?
-2?
It is. How many times did I move the comma? Look where it was. It was here, right?
Yes,
How many times did I move it from there to there?
twice.
Do you see? You
Right.
good now?
Yes.
Wonderful. Leachilwe, you may unmute, my darling. Which 0 are we coming? Oh, okay. You're good. You're good. Wonderful. So remember, guys, I can't just write comma 0, 5, 5, 3, right? Because that doesn't look right. So this one in front is just the, it's fine, Lachili, you don't have to unmute. As long as you understand now. So I put this 0 before the comma just so that you understand that this is a very small number. It's a decimal number, right? I can't just leave it as comma 0, 5 because that's not how we write stuff in maths. Okay, great. So now that we're understanding, let's do a bit more of these things. Let's do more of these. I'm not gonna erase these so that you understand. I'm just gonna write on the side here. Let's do number C. 5,14 times 10 to the power of -4. Okay, am I moving my comma right or left? Left, how many times? 4 times, so I need to add how many zeros before that 5? How many zeros do I need to add? 3 zeros. Beautiful, guys. Senyani, I'm hoping that's a mistake. Because remember, we're here, right? If you move 1, and you still need to move 3 more times. That means you add 3 zeros. So it's 0, 0, 0, 5, 1, 4. And then, of course, that 0 that is in front. And if you're not sure, check yourself, right? If it was over here, and I'm moving it there, that is 1, 2, 3, 4 spaces. Okay, guys. Okay, let's do a few more. Let's do number D, which says 4,93 times 10 to the power of 7. Am I moving it left or right? Are we going to move this one left or right? Right. How many times? 7. So if I have 2 numbers, how many zeros do I need to place there? 5. Nice, guys. 4, 9, 3. 1, 2, 3, 4, 5. Okay. I don't know if we should do more, but no, there's some other stuff I want us to do. Let's have a thumbs up, thumbs down, so that I move on from this section. Thumbs up, thumbs down. Everyone was confused. Are you with me now? Are we now sort of on the same page? Beautiful. Okay, that's great. It's a lot of thumbs up, so I'm feeling good. Screenshots. Let me do this. Zoom out for us. There we go. Can you take your screenshot? Then I'm going to move on from there. Okay. Okay, we've done this already, but okay, this is what I want us to do before our brain break. Now, we're going to use scientific notation to solve these, okay? Put away your calculators. That's not what we're doing right now. Okay, so we're going to use scientific notation to calculate these. So that means, in the first place, they have to be in scientific notation. Now, let's do that. Okay, let's start with the first one. First one, 135,000. Where do I want my comma? After the 1. So 1, comma, 35 times 10. Are we moving it to the left or to the right? Left. Is it a positive or a negative exponent? Let's see if you remember. A positive exponent. And how many times are we moving it? Let's see. From there. 1, 2, 3, 4, 5 times. So it is 10 to the power 5. Right. Times for the second one. For the second one, where do I want my exponent? After the 2, so 2, comma, 4, 6. Once again, I am moving it to the left, so that is a positive exponent. How many times are we moving this? Okay, this is going to be a little bit tricky, so I'm going to zoom in so we can see properly. Okay, because I myself can't see. Let's see from there. 1, 2, 3, 4, 5, 6, 7, 8. Woo! This is why zooming in was a good idea, because I was definitely going to miscount that. 8 times. So it is times 10 to the power of 8 equals. Now we need to multiply 1 comma. I know I said put away your calculators, take them back out. Hopefully you know how to do long division, but multiplication, long multiplication, but I'm not going to do that now. We don't have time for that. I just want to know 1,35 times 2,46. These two guys is what I want you guys to multiply. These two. That is 3,321 times 10. Now, what are we going to do with these guys? These two 10s? We're going to add what? What are we going to add? The exponents. So then it's times 10 to the power of? Saying says 13. Beautiful. Beautiful, guys. Okay, let's do the next one. Which is very complicated, but it's fine. Let's do it. We can do it, okay? So we want our comma where? After the 9. So 9, comma, 8, 7, 6, 5, 4. Times. Where do we want the comma in the second number? After that? 1. So it's 1, comma, 2, 3, 4, 5, 6. Wait, I forgot to do times 10. This says times 10. Did we move it to the left or to the right? How many times? And is it positive or negative? Is it positive or negative? Nice. Positive. 1, 2, 3, 4, 5. Thank you. And for the next one, is it positive or negative? Positive, and again, 1, 2, 3, 4, 5. Now, I need you guys, you calculator boffins, please. 9,87654 times 1,23456. Let's hear what it is. Anyone? Okay, let's see. 12, 1, 2, 9, 3, 1, 8, 1, 2, 2. Now let's do our whole adding of exponents. It's going to be times 10 to the power of 10. Now, is this in scientific notation, guys? No. What's the problem with this answer? It's over 10. So where do we actually want our comma to be? After the 1. So it's times. Nope, equals, not times. Equals. Okay, so it wants to be 1, 2. 1, 2, 9, 3, 1, 8, 1, 2, 2 times 10 to the power of 10 times. Did we move it left or right? Left. So is it positive or negative? Positive what? Positive 1, guys. I haven't added it yet, right? And then in the last step, we add them. So it is 1, 2, 1, 2, 9, 3, 1, 8, 1, 2, 2 times 10 to the power of 11. Okay, I want us to do one last one. Let's do this one. Let's do the absolutely last one, 1, 4. Okay, so where do I want my comma? For the first number of 1, 4, 1.4. After the 6, so it's going to be 6, 39 times 10. Are we moving this comma left or right? Right? How many times? And is it positive or negative? Nice, Sanyani. Sanyani is very fast at this before I even ask. So we know it's negative, and let's check if 7 is indeed the number. 1, 2, 3, 4, 5, 6, 7. Yes, it is. 7 times. Second number, where do I want this number? After the 5, so it's 5,87. Once again, we're moving it to the right, so I'm going to have a negative exponent. How many times are we moving it? 5. 1, 2, 3, 4, 5. Now, what's 6,39 times 5,87? Nice, 37, 5093 times 10. What's negative 7 plus negative 5? That positive negative does what? Becomes a negative. So my answer is negative 12. So this is 37, 5093 times 10 to the power of negative 12. Is this scientific notation? No. Where do we actually want our comma? After the 3. So it's going to be 3, 75093 times 10 to the negative 12 times 10. If I moved it left, is this positive or negative? Positive what? 1. So it's just the 1, right? So then my final answer is 3, 75093 times 10 to the negative 11. Beautiful. Thumbs up, thumbs down. Let's hear. And for screenshotting, here you go. Okay, that's more thumbs up than I've gotten in a while, so that's wonderful. Great, guys. Okay, brain break. Who's ready for a brain break? I think our brains need to relax. Yes, Nelson, you can unmute yourself.
Hello, ma'am.
Hi. Do you want to do the brain break?
Yes, ma'am.
It's a different one. If you multiply this number with any number, you'll always get the same answer. What is this number? Do you know what number that is?
1.
No, it's not 1. Does anybody know? Look in the chat. I think someone is helping you there in the chat.
Yeah.
The answer is 0. Because look, guys, if I say 2 times 0 or 1,000,000 times 0, I will keep getting 0. Do we see? Nice one, guys. Okay, Tlali, are you ready for yours?
Yes.
Okay, out of A, B, and C, which domino will complete this series? Do you have an idea?
I think C,
Why?
because they not sure, but I think it's because they add to.
They add 2, is that what you said?
Yes.
From which one? It is C, but I'm not sure what do you mean by they add 2. Look here, guys, we're counting. If there's nothing there, it's 0, right? Then it's 1, 2, 3. So the one at the bottom has to be what?
4.
Oh, nice. Then the other way around as well. 2, 3, 4, 5. So one at the top has to be 6. So which one out of these 3 has a 4 and a 6? Number C. Beautiful,
C.
guys. Nice, nice, Tlali. Okay, and my last one, which one is the next one in this pattern? Which shape is the next one in this pattern? And why? It would be nice if someone would tell me why they gave me that answer. Is it A, B, or C? Ali says B. Nelson says C. Okay. Why, guys? Do you guys have any justifications for your answers? Yes, Nelson, you may unmute.
Because when it starts by the circle, ma'am, it's like 0. Then when it goes to the acute angle, it's like 2. And then when it goes to the triangle, it's 3. And the quadrilateral, it's 4. And then it must go to the pentagon to continue to 5, ma'am. So the pattern goes from numbers, ma'am.
Beautiful. That's correct, guys. But a circle is not 0. A circle is just one very long side. Do you see that? Because there are no corners. So it's just one side that keeps going. So this is 1 side, 2 sides, 3 sides, 4 sides. And everyone got this one correct by saying C because we need 5 sides. Brilliant, guys. Beautiful, beautiful. Thank you, Nelson. Okay, are you guys ready to finish off this lesson strong? Hopefully you liked that brain break. Nah, it was more exercise, unlike the did you rathers or would you rathers. I'll find more interesting brain breaks for us. It was short. You guys are smart, Leachilo. I can't control that. It's you who's smart. Guys are just getting it. Okay, let's get going. Now, let's see what's going on over here. Okay, let's see what's going on over here. So this time we are not multiplying, we are adding. Now, can we add these numbers as they appear right now? Yes, you guys are. Why can't we add these numbers, guys? Does anyone have an idea of why we cannot add these numbers? Why can't I add x plus y? That's true. Nice, guys. The exponents are not the same, which means they are not like terms. So that means we need to make these exponents the same before we can do anything with these numbers. Now, is it possible for me to take a power of 3 and make it a power of 5? You guys think that's possible? Is there any way I can move this 3 exponent and make it 5? How is it possible, Maureen? Take a 3 and make it a 5. Remember this number. Okay, let's rewrite this number in full, right? So it's going to be 2, 3, 0, 0. And if I wanted it to be a power of 5, I would have had 2 extra zeros. Do I have these 2 extra zeros here? No, I don't have these 2 extra zeros, right? Remember, Marlene, these zeros are at the end of the number, not in the beginning. Okay? They're at the end of the number. So it is not possible to take a power of 3 to make it a power of 5. But can I take the power of 5 and make it a power of 3? So this number is 7162345. Right? And if I want to make it a power of 3, where would I have to place this comma? Where must I place this comma for it to be a power of 3? After that, nicely, Achille, after the 6. So then it's going to be 716 times 10 to the power of 3 plus 2,3 times 10 to the power of 3. Now, can I add them? Wait, let me stop there. Do you all understand what Achille and I did just now? Thumbs up, thumbs down on that. Thumbs up, thumbs down. Do we all understand how we changed the power of 5 to the power of 6? I mean, power of 3. Excuse me, power of 3. Okay, I see thumbs up. Okay, so instead of moving it all the way there, we only moved it twice. 3 times, excuse me, which is what influenced this. So now can I add them? We have 10 to the power of 3, 10 to the power of 3. Is it possible to add them? But what do we add? We only add the, what do we call these numbers in front again? We only add, no. Add the coefficients. Okay, it's like having 7x plus 4x. We don't say it's 11x squared. We just say it's 11x. Okay, so then it'll be, thank you, Marlene, 718,3 times 10 to the power of 3. Now we have a very specific instruction here. Leave the answer in scientific notation. Is this in scientific notation? No. Where do I want my comma? After the 7. So I want it to be 7,183. I already have a 10 to the power of 3. Now, where did we move the comma, left or right? Left, so is it positive or negative? Positive, how much? 2. So then my final answer is 7,183 times 10 to the power of what? Of 5. Beautiful, guys. I think we can do one more before we all go off. Okay, I'm going to rewrite. I think the best thing is to rewrite both these numbers. Okay, so here, how many zeros do I need in front of the 2? I only have one space to move, so how many zeros must I put in front of that 2? 3 zeros. So this is 0, 0, 0, 0, 2, 3. Plus, how many zeros do I put up before the 6? 2. So it's 0, 0, 0, 6, 5. Okay, so between the 10 to the power of 3 and 10 to the power of 4, which one do you think will work? Which exponent are we taking? Kali says 10 to the power of 4. So let's see. 1, 2, 3, 4. Yes, it can work. 1, 2, 3, 4. It can work. It can work either way, right? If it's 1, 2, 3, it'll end there. If it's 1, 2, 3, it'll end there. It's still this, it will work with both of them. Doesn't matter. Okay, I'm gonna take the 3. So if it's 3, it's 1, 2, 3. So it's gonna be 0, 23 times 10 to the negative 3 plus this one stays the same. So I'm gonna leave it the same. Now what is 6,5 plus 0,23? 6,5 plus 0,23. It's 6,73, I believe, times 10 to the power of negative 3. Now for you who don't believe, let's do it with the 10 to the power of 4. Okay? So I'm going to leave this one as 2,3 times 10 to the power of negative 4 plus this one will be 1, 2, 3, 4. So it's going to be 65 times 10 to the power of negative 4. What is 65 plus 2,3? 65 plus 2,3 is 67,3 times 10 to the negative 4. Now, is this in scientific notation? Nope. So I'm going to move my comma to 6,73. I don't know why my pen just did that. Times 10 to the negative 4 times. Did we move it left or right? Left. So my exponent is positive what? How many times did we move it, guys? From there to there. 1. So it's just 10 to the power of 1. So then if we add my exponents, I'm left with 6,73 times 10 to the power of negative 3. Do you see it's the same answer? So whichever exponent you chose, it is what it is. Don't worry about it. You would have